Hello, today we'll talk about conditional probability and Bernoulli or binomial distributions. So I'll explain everything from a tree diagram. So for example, you have some event B and some other possibilities. And here you have A and A bar, meaning A and not A. And you want to know the probability of A knowing that B occurred. Here, if you follow that branch, you will have a probability here, P, and here Q. On that branch of the tree, you have the probability of B and A, which is P times Q, because you multiply along the branch, okay? But in these probabilities, this one here is the probability of A knowing that B has occurred, because you are here. So B has already occurred, okay? And this one is the probability of B occurring. That's how you draw the tree diagram. So what it means is that the probability of B and A is your little p here, probability of B times Q, which is the probability of A knowing that B occurred. So the probability of A knowing B is probability of B and A divided by probability of B. That is called a conditional probability. So that will be our first topic. And I'll give you examples in other videos. Now, so this is, for example, the probability of, I don't know, going skiing this winter, knowing that you live in a given town, okay? And we'll do exercises on that. So what is a Bernoulli distribution or Bernoulli trial? A Bernoulli trial is a situation where you have only two possibilities, only two things can happen. It's a success or a failure. And you will have a certain probability of success. And of course, we'll denote Q the probability of failure, but it will be 1 minus P because the total must be 1. And if you want, you can call it S bar because it's the opposite event of S. So if you have only two possibilities like that, it's called a Bernoulli trial. And if you repeat this, again and again, several times, but with the same probabilities, which means, for example, if you draw a ball from a box and there is only one black ball among 4 balls, for example, and let's say that you can decide that success is having a black ball or success is having a white ball. It won't change the calculation because they are symmetrical. So black ball, white ball. So having a black ball here is 1/4. The probability of it is 1/4. And the probability of having a white ball is 3/4. If you want it to be a binomial distribution or binomial trial, you have to repeat exactly the same experiment. So you have to have the same probabilities here which means after drawing a ball, you put it back in the box, because if you don't put it back, it changes those numbers and it's not binomial anymore. And you can do this a lot of times. And there's a very famous formula to compute the probability of for the binomial trials. Is the formula is this. And the proof of this formula is a proof by induction. Now, what are these letters? P, the little P here, you know it. It's the probability of success if you play once. Probability of success if you play once. This is Q, the probability of failure. It's 1 minus P. Now, N is the number of times you play. Or you repeat the experiment. Okay? And now K is what you want to compute. If you want to compute the probability, if you play, for example, 10 times of winning 4 times, this is of winning K times. It's the number of times you want to win. The probability of winning K times if you play N times is NK P to the power of K, 1 minus T P to the power of N minus K. This number here, NK, is a binomial coefficient. So you can find it by computing factorial N divided by factorial K, factorial N minus K, or you can compute it with your calculator. By the way, your calculator knows how to do this. With your calculator, you can compute things like P equals K, or P of X is like inferior to K. It depends on the calculators, because this would be a sum. It would be X equals 0, X equals 1, X equals 2, X equals 3, and so on, until you get to X equals K. And your calculator does that. Something else you have to know about binomial law is that the expected value of your law is N times P. The expected value is if you play a lot of times, what is like the expected of winning frequency, something like that. It's yes, it's the probability of winning if you play many times. It's like it's like a mean. If you compute a mean, it's the same thing. Now what I wanted to show you. The standard deviation of X is the square root of N P 1 minus P. We'll talk about standard deviations later in this course. And what we call variance is what is below the square root here. We'll talk about this later. It's about these values are meant to show like the expected value is around which value are the values of the probabilities evolving, and the standard deviation shows how far they are from that mean value or from that average value. The fact that they are far away from it or close to it is computed by the standard deviation. We'll talk about this later.